Hi Chem Gang. In this example, we're looking at this reaction of nitrogen monoxide with hydrogen gas. They react, so we have our reactants to create ammonia, which is NH3, plus water vapor, so H2O. And the question is, if we take this reaction and put it in a closed reaction vessel, when the above reaction has occurred to its fullest extent, so it goes completely through, state how many moles of each of the compounds will be found in the vessel. So how much NO will we have in there? How much nitrogen monoxide we will have in that vessel after the reaction finishes, how much hydrogen gas will we have, how much ammonia gas will we have, and how much water gas will we have. Given that, we start out with 4 moles of nitrogen monoxide and 15 moles of hydrogen gas. So the first step is to find out which of the reactant is the limiting reactant and which one is the excess reactant. So to do that, what we're going to do is take out our starting amounts of each reactant and figure out how much product is made. We don't have to do it for both products. I'm just going to do it for ammonia. That will tell me which one is the limiting reactant. So let's start out with our nitrogen monoxide. So we have 4 moles of NO, and we are going to find out how much product, how much ammonia that makes. So we're going to use a conversion factor that will end up with us telling us how many moles of ammonia we'll have at the end. So the conversion factor we're going to use is based on nitrogen monoxide and our ammonia. So we're going to put nitrogen oxide on the bottom because we want to be able to cancel it out. So we're going to put moles of nitrogen oxide on the bottom and moles of our product, NH3, on the top. That way our moles of NO will cancel out, leaving us with what we're looking for. And the relationship we're going to use is based on the coefficients in front of our reactant and our product. So this is our stoichiometric relationship here, which is 2 to 2. So that means for every 2 moles of NO that go in, we'll get 2 moles of NH3 as a product. Then we can go ahead and do our calculation. 4 times 2 is 8 moles. Divided by 2 moles will give us 4 moles total of ammonia. So if we start with 4 moles of nitrogen monoxide, we will get 4 moles of our product, ammonia. Do the same thing now with our hydrogen gas. We want to see how much product it makes. That's going to help us determine whether it's an excess reactant or a limiting reactant. So we have H2. We're going to use a conversion factor, and that's going to help us find out how much product of ammonia that makes. So if we're going to cancel out our moles of H2, we're going to need moles of H2 on the bottom, which is going to leave us moles of our NH3 on top. And this time we're looking at a ratio of 5 moles of H2 creates 2 moles of NH3. So that's going to give us 15 times 2 gives us 30. Divided by 5 will give us 6 moles of ammonia if we start out with 15 moles of hydrogen. So in this case, our limiting reactant is going to be our nitrogen monoxide because it makes the least amount of product. So this is our limiting reactant. And this hydrogen gas is our excess reactant. We're going to have way more than what we need to make our NH3. So from this, we actually figured out what is in the reaction vessel at the end for our nitrogen oxide. So if that's the limiting reactant, then we know that at the end of the reaction, all of this is going to be created. So what am I going to call this? End amounts. How about that? So the end amounts in our reaction vessel is, first of all, we're going to have 0 moles of our nitrogen monoxide because it is the limiting reactant, which means that all of it gets used. And if all of it gets used, then that means we also know that after the reaction takes place, we're going to have 4 moles of NH3 because that's the product. Now we still have left to find out how much H2 will have as the access reactant. And we still need to know how much H2O we have left as the other part of that product side of the reaction. Now, the next step, we can actually find out how much water is produced based on, now that we know that it's the nitrogen monoxide that's the limiting reactant. So we know that all of that NO is going to be used, so we can use that amount, 4 moles of NO. We can use that amount to find out how much H2O product is going to be made. Okay, so again, this limiting reactant not only tells us how much ammonia is made, but it can also tell us how much water is made as well. So we're going to use our ratios of moles of NO to moles of H2O. And we see here that we have 2 moles of H2O versus 2 moles of NO. So that means that if you have 4 moles of NO to start, this really is just a 1-to-1 ratio. So 4 times 2 is 8, divided by 2 is 4. So if we have 4 moles of nitrogen monoxide to start with, that's going to give us 4 moles of H2O. So one more piece of the puzzle has been done here. So the last piece of the puzzle is really how much H2 do we have remaining in that vessel. So to do that, we have to figure out if 4 moles of ammonia and 4 moles of H2O are produced, how much H2 was needed in order to create that. So to find out how much H2 was used, we can either start with water as our product or ammonia as our product. It really doesn't matter. I'm going to start with ammonia. So we know that we have 4 moles of NH3 made, and we're trying to figure out how many moles of H2 were needed to make that amount. So that's going to give us moles of H2. So how many moles of H2 were used to create that 4 moles of NH3? We're going to put moles of NH3 at the bottom so that we can cancel out our moles. And going back again to our ratios here, it's 5 moles of H2 creates 2 moles of NH3. So this cancels out and we get 4 times 5 is 20 divided by 2 tells us that it takes 10 moles of H2 to create 4 moles of NH3. That's key. That's how much H2 was used. If we started out with 15 moles of hydrogen gas and 10 moles of it were used. Remember, this is the excess reactant, then that means there's going to be 5 moles left over of our hydrogen gas in that reactant vessel that didn't get used. So there is that final amount, 5 moles of hydrogen gas. That's our excess reactant, and that's what's going to be left behind when all of our nitrogen monoxide is used, as it's the limiting reactant. So I hope that helps in explaining how to do just another example of a limiting reactant and an excess reactant problem. If you have any questions, please post to the unit Q&A. Bye for now.